Nature has some pretty amazing recipes. And today we're going to break down one of my favorites. It's the one for fog. Yeah, that beautiful, sometimes kind of spooky thing. Let's get right into it. So, have you ever walked through a really thick, soupy fog? Well, what if I told you that you were actually walking inside a cloud? Seriously. That's all fog really is. It's just a cloud that's decided to chill out right at ground level with us. All right, so let's start with the absolute core ingredient here. Okay, so here's the deal. Fog is, at its heart, just a cloud that's touching the Earth. The real magic, though, happens when the air temperature drops to something called the dew point. Once it hits that magic number, all the invisible water vapor floating around in the air, well, it just can't stay a gas anymore. It has to condense into these teeny tiny visible water droplets. And boom, that's what we see as fog. So, we see fog everywhere, right? Over a field, rolling in from the coast, clinging to a mountainside. And yeah, they all have these different kind of technical names. But here's the secret. They're all created using the exact same simple three-step recipe. And here it is, the universal recipe for fog. It's so simple. First, you start with moist air. Got that? Good. Second, you have to cool that air down to its dew point. And third, that vapor condenses into the droplets we can actually see. And what's really cool is that, as we're about to find out, every single type of fog is just a different variation on how you get step 2 done, how you cool the air. So let's talk about the first way to get that cooling done. This is probably the one you're most familiar with, even if you don't know it. We'll call it the chill from below method. And this brings us to what's called radiation fog. You know that classic, almost spooky morning mist that just blankets everything? Yeah, that's it. That's the one. It's your classic morning fog. Okay, this is what I find so fascinating. The conditions have to be just right for this to happen. You need clear skies, right? So the ground can just beam its heat out into space all night long. Then you need really calm winds. We're talking less than 5 knots. Because if it's too windy, the air just gets all mixed up, and you won't get that nice cold layer forming at the bottom. And of course, you need a long, cool night to give it all enough time to happen. It's like a perfect storm, but for fog. All right, next up we've got advection fog. Now, advection is just a fancy word that means moved by the wind. That's it. So picture this. You've got this warm, really wet air, and it's blowing over a much colder surface. Think of it moving over a chilly ocean current or maybe a big field that's still covered in snow. So let's break down the difference, because in the real world, these two are totally different beasts. Radiation fog, that's your calm night land-based fog. The sun comes up and poof, it usually burns off. But advection fog? Oh man, that's a whole other level. This is the stuff that folks on the coast and sailors have to deal with. It can form when it's windy, it can stretch for miles and miles over the ocean, and it can hang around for days. We're talking major visibility problems. Okay, so besides chilling from below, there's another way to cool the air. This time, it's the movement of the air itself that does the trick. Let's call this the forced cooling method. And this gives us upslope fog, which is it's so beautifully simple. Imagine a moist wind blowing along, and it runs into a mountain. Well, it's got to go somewhere, right? So it's forced to go up. As that air rises, it expands, and when air expands, it cools down. It's just physics. And if it cools down enough to hit its dew point, well, you guessed it. You get a cloud, basically hugging the side of the mountain. Okay, this next one is one of my personal favorites, mainly because it feels like it's backward. It's called steam fog. You might have heard it called sea smoke. It's that effect where it looks like a lake or a river is literally steaming on a super cold morning. But here's the thing, the name is kind of misleading. That water is definitely not boiling. The whole secret here is that massive temperature difference. You've got extremely cold, dry air moving over water that's, by comparison, much warmer. So what happens? The warm water evaporates a little bit into that super cold air right above it. That cold air immediately gets overloaded with moisture, and it condenses instantly. So see, it's not about warm air cooling down. It's about cold air getting a sudden, massive dose of humidity, super fast. All right, let's turn the thermostat way down. We're going into sub-zero territory now. And this is where things get really interesting, because we have to talk about the difference between fog made of liquid water and fog made of actual solid ice. Now, this is something that trips a lot of people up, but the difference is so important, especially if you're a pilot or even just driving in these conditions. So what is the difference between freezing fog and ice fog? Okay, this breaks it down perfectly. Let's start with freezing fog. This stuff is made of what's called supercooled liquid water droplets. Just think about that for a second. It's water that's actually below freezing temperature, but it hasn't turned to ice yet. The second these little liquid droplets touch anything solid, like a road or an airplane wing, bam, they freeze instantly. That's how you get that treacherous black ice. Now, ice fog is different. It only happens when it's ridiculously cold, like think -30 Celsius, and it's made of tiny ice crystals that are already frozen solid while they're just floating in the air. And hey, just to round things out, did you know you can get fog just from rain? It happens when warmer rain falls through a layer of cooler air near the ground. A little bit of that rain evaporates into the cool air, bumps up the humidity, and if it hits the saturation point, you get what's called frontal fog or precipitation fog. And really, that brings us right back to where we started. This quote from the U.S. Captain's Training Manual just nails it. At the end of the day, it doesn't matter how the fog formed or what fancy name we give it. The process is the exact same one that creates the clouds way up in the sky. So think about it. We've seen the ground do the cooling. We've seen a mountain do the cooling. We've even seen what happens when it gets crazy cold. But every single time, it all came back to that one simple recipe. They were all just different methods for getting step 2 done, cooling that moist air down to its dew point. I mean, isn't that incredible when you stop and think about it? A simple drop in temperature, that's it. And it turns invisible gas into this massive, visible thing that can literally ground airplanes and shut down highways. It's a pretty powerful reminder of how these huge, invisible forces are constantly shaping the world we see. And it kind of makes you wonder, right? What other incredible forces are out there all around us working on principles that are just that simple, and we just haven't noticed them yet?